Okay, so just to review a little bit of inverse functions, years ago, a student of mine came up to me and says, hey, I know you're into cycling. Why don't you come out and visit my family's bike shop? We're on the 61,000 block of Mound Road. And I just looked at him and I said, well, there's no way I'm going to go all the way out to 28 and Mound. I live here in Royal Oak. And he was shocked. I didn't pull out my phone and look up his address or anything like that. I just knew. Now, how did I know? Well, I applied the inverse function. The function is something that takes a spot in the domain or a value X in the domain and maps it to a spot in the range. Now, our function in this case is one that would help out the postman if you're writing down the addresses, if you're creating addresses. The way the addresses work on your major north-south roads is you multiply by 2,000 and then add 5,000. So for instance, at the corner of 11 Mile and Woodward, there's a gas station, car wash, Jack's Car Wash. 2,000 times 11 is 22,000 plus 5,000 is 27,000. That's great. That's applying the function. F of 11 gives you 27,000. Well, what I did with my student is I kind of did the opposite of that. I somehow or another went from the address back to the mile road. And that's a cool trick, but it's undoing what the function does. It's doing the opposite of that. And that's the nature of an inverse function, is that it undoes what the function does. So let's think about this a little bit more carefully. Now for convenience, I'm going to rewrite my function. Instead of writing it in thousands, I'm just going to write it as 2x plus 5 instead of 2,000x plus 5,000. So that means if I put in a 1 for x, I get 7. So 1 mile road would be in the 7,000 block, or 3 mile road would be in the 11,000 block, and 5 mile road would be in the 15,000 block. Actually, you should just write 15 there. Assuming that this went all the way that far south, it might not go that far south. But here are our points right here. And that's our function, y equals f of x. But what I used with my student was kind of the opposite of that. I want something that's going to take the mile road as the input, just give me the address as the input, and give me the output of the mile road. So the address is the input, output is going to be the mile road. So let's write it here like this. So if I input a 7 is in the 7,000 block, what should I output from my inverse function? What I want to output is the 1. I want to output the mile road. So for instance, if I put in a 15, I should output a 5. That's my address, output the mile road. And that's kind of a nice little thing to have if you're trying to navigate your way around. Kind of tells you where you're at. So, okay, let's plot those points. Those are going to be right here. This is going to be our inverse function, y equals f negative 1 of x. Now that negative 1 does not imply anything with the reciprocal. A lot of people want to say that that's the reciprocal function, f negative 1 of x. The reciprocal of that would be 1 over 2x plus 5. But if you plug in some numbers here, you see that that doesn't work. Plugging in a 7, that'd be 14 plus 5 is 19, that'd be 1/19. That's not outputting what it needs to. So whatever it is, the inverse function is not the reciprocal. They're just different things. Now, one of the things I do want you to notice is that there's some symmetry around this line y equals x. And the graph of your function is symmetric to the graph of its inverse around that line. They're mirror images of each other. So the graph of f and F inverse are mirror images around the line y equals x. All right, that's just simply one of the conclusions that I'd like you to know. But there's other things that you should know, and to kind of review what you saw on the original video about this stuff, here's how you would actually find an inverse function. You start out replacing f of x by y, interchange x and y, solve for y, and replace it with that inverse notation. So let's see what that would look like for our current function. So that would be f of x is 2x plus 5. Start by replacing y by f of x. And then we'll interchange these. Now we have to solve for y. So the first thing I'll do is subtract 5 from both sides, and then divide both sides by 2. And that's pretty much it. That gives you 3 points out of 4. But please, finish it up. Write it as f inverse of x equals x minus 5 over 2. That's the final step there. Now, with that function, we can actually look and see that it satisfies the one thing that I said it does, is that the function and the inverse are mirror images of each other around the line y equals x. Let's see that that's true. So I'll just open up a new Desmos page here. So Desmos, come on. All right, doesn't open up in a second. I'm going to go back to the other page, just use that one. There we go. So let's graph both of those functions, see if they are mirror images or reflections of each other. So y equals 2x plus 5. And here's kind of a cool trick that you can do on Desmos, but not your graphing calculator. Remember, as one of the steps that we did along the way, we interchanged x and y, and then we solved for y. But this is equivalent to this. So I can just type in this statement right here. The nice thing about Desmos is you don't have to solve for y. This is a function that's kind of defined implicitly, would be the fancy word for it. So those are mirror images of each other. If you type in a line y equals x, you can see that a little bit easier. For instance, let's take a look here. 0, negative 2.5, that's on the graph of my inverse. If I reflect it around here, that means at negative 2.5 and 0 should be a point on my original graph. Oh, that's true. Let's check out the y-intercepts and the x-intercepts. 0, 5, and 5 and 0. Again, they're mirror images of each other. So the input for the one is the output for the other one. Nice. Now what that leads to is what is called the property of inverses, or what I want to cover next, I should say, is the property of inverses. And it's a quick question for you on an exam or on a test. But let me show you what they actually mean for you to do. So the property of inverses, and I wouldn't copy this down, just kind of sit back and enjoy for a second. Property of inverses says this: if I have a function and its inverse, then f of f inverse of x is x. Or f inverse of f of x is also x. Geometrically, what that's saying is that if you do a function of some value, you get to here. And then if you follow it up with the inverse function, you get back to where you started. Or if you wanted to start from here and do the inverse function and follow it up with a function, again, you're going to get back to where you started. Let's see that in this case. So this is good practice with function composition. I need to start by recalling what f inverse of x is. That's up here. F inverse of x is x minus 5 over 2. So let's just put that in right here. Now what? Now I want to go to the rule for f. The rule for f says whatever you put in here, you're going to multiply by 2 and then add 5. So, okay, let's do that. Let's see, 2 times whatever, and then add 5. That whatever, in this case, is 2x, or excuse me, is x minus 5 over 2. What you should see is that this has some nice simplification. The 2's cancel, leaving me with x minus 5 plus 5. And that further cancels. That just gives me x. Oh, okay. That's kind of what they said. That's the whole property of inverses thing. Same thing happens over here with f inverse of f of x. Starting the inside here. F of x is 2x plus 5. And now go to the rule for f inverse. The rule for f inverse said this. Whatever you put here, you're going to subtract 5 and then divide by 2. So let's see if we can't do that. Can you hear my dog barking? Is it coming through from the audio? No? Okay. 2x plus 5, like that.
Yeah, now we hear it.
Now you hear it? Now that I've directed your attention to it, there's some nice simplification here. Can anyone see anything in the numerator that simplifies? How about minus 5 and plus 5? They cancel. That leaves me with 2x over 2. And that simplifies to just x. Now, I could give you stuff like this to practice function composition. I'd probably just give you a separate problem on function composition. But here's what I could do on an exam. I could say, all right, these things, this is true, and this is true. And maybe even show you the calculations. But afterwards, after I get to this conclusion, I say, what does it tell you about the two functions? And the correct answer is that they have to be inverse functions of each other. That's what I'd be looking for, is that these two are inverses of each other. So just a little heads up, there is a problem in the homework that asks you about the inverse property. And that's what this is. So that when you compose these two functions in either order, you get back to where you started, which is x. Okay, let me pause for a second. Anything on those two, or this one right here? It was a nice long intro example. Let's try a little bit more. So here's one directly from your homework.
Can you put do you hear me?
Yes, yeah, what's up?
I need to copy the last one. I didn't copy it. The last line, please.
Sure. There you go. You're good?
Thank you. Yep, thank you.
Yeah, no worries. All right, so the next one I want to look at is coming directly from your handout, or excuse me, not your handout, but from WebAssign. And it has a restricted function here. G of x is x squared plus 10x for x greater than or equal to -5. Let's look at this first for a moment, and let me discuss this function a little bit in conjunction with the HLT, the horizontal line test. So let's see, not that one. Let's see. Section 2.8, here we go. All right, so let me give you a copy of this link here. So I just want to take care of one thing real quick. I'll put a copy of this link in the chat for you. If you want to open it up, great. If you don't, that's fine too. But I'm going to start down here with y equals x squared plus 10x. And because of the nature of the problem, I want to find where this function actually crosses through an equals 56. So I'll explain a little bit more about that in a minute. It all goes back to the problem that we were given to begin with, which was this one, find G inverse of 56. Yeah, we still got to work on that a little bit. Let me go back here. And we're going to work with finding the value of x that gives me 56 for y. So that'd be this equation. X squared plus 10x equals 56. And I'll go back and explain it a little bit why we're doing this one here. But if you're asked to solve this, this is just a quadratic equation. You could pull out the big guns with the quadratic formula. I wouldn't recommend it. I'd recommend you factor it. So we need two things that multiply to 56 and add the positive 10. Actually, I should say negative 56 and add a positive 10. Let me throw out 14 and 4. One of these has to be negative and one of them has to be positive, so that when I multiply, I get a negative number here. The larger of these two has to have what sign?
Minus.
Has to have this sign. Has to be the same as that one. This one we get the minus, and that gives me two solutions, negative 14 and positive 4. Okay. You can actually see those two solutions on the graph if you scroll down enough. So let me kind of zoom down a little bit or zoom out a little bit. And I think that might be enough. No, not enough yet. There you go. So right here, negative 14 and positive 14. Yay. So there's two solutions. Realistically, I only want one solution. But that's where the restriction that they made comes into play. If you look back at the original problem, they said we only want to consider the graph for values of x greater than or equal to -5. So if I make that restriction, let me shut this graph off and turn this graph on. Now I've got a graph that, oh, okay, it's only like half of what it was, right? Because I'm looking at values of x that are greater than or equal to -5. So the only one solution that I've got is right here, 4 and 56. And that makes sense. X and I think they call that G of x. So if I put in a 4, I get a 56. I can see that. 16 plus 40 is 56. Likewise, if you plug in a -14, you'll also get 56, but I don't want to confuse the issue with that one. This is the only one that we really want, because that's something that satisfies x is greater than or equal to -5. So that's the function. Here's the inverse function. The inverse function reverses these roles. So instead of 4 and 56 here, what would I write here? You input a 56, and what would you output? Well, when you go from the function to its inverse, you're interchanging these. So that would be a 4. So the answer to your question here, original question says find G inverse of 56. The answer is 4. Let's go back here. If you take this and put it into the function for G, your output's going to be 4. That's what you're looking for. There was a little bit of something interesting going on here, though. Originally, we got two solutions. We got 4 and 56 and -14 and 56. That's kind of a problem, because that means that over here I get 56, and what else? What should I write here? What's another possibility for me? 56 and -14. But this is no longer a function, because each input doesn't have just one output, it has two outputs. In other words, G inverse in this case wouldn't be a function. Let's understand that a little bit. I'm going to shut off this. My original graph looked like this. Does the original graph pass the horizontal line test? You can nod or put something in the chat.
No.
Rachel, what do you think? Does the original function pass the horizontal line test? I'm getting a no from that. So you're right, it doesn't. It fails the horizontal line test. Because that fails the horizontal line test, that means its inverse is not going to be a function. Here's the graph of its inverse. I'll shut this off. Does the inverse pass the vertical line test? No, it doesn't. Just doesn't, fails it. That's because the original function didn't pass the horizontal line test. But if we make the restriction that x has to be greater than or equal to -5, is this something that passes the horizontal line test? Janae, what do you think? Does this pass the horizontal line test? Let me make that a little bit darker here for us.
Yeah.
Yeah. And so its inverse should pass the vertical line test. Now, here's the graph of its inverse. And if you're curious, here's the line y equals x. You can see that these two functions are reflections of each other around that line. So yeah, the inverse passes the vertical line test. Perfect. That's exactly what we're hoping for. Now, there's one last little thing that I wanted you to know in terms of these properties or things about the inverse function. And we can see it here at the bottom of our handout. The domain of F is the range of G, and the range of G is the domain of F. In other words, the domain and range interchange when you go from the function to its inverse. Let's see that for our particular functions. We'll start by looking at the original function. This is your graph. It's true for when x is greater than -5. So that's its domain. So g of x has a domain starting at -5 to infinity. And a range The range starts at negative 25 and moves up towards positive infinity. So the domain is negative 5 to infinity. The range is negative 25 to infinity. If you're to look at the inverse function, you've got this. What's the domain of the inverse function? Where does the graph start? Along the x-axis. Trying to keep my button on this to highlight that, but it starts at what x value? Where does the graph of this begin along the x-axis?
Negative 25.
Negative 25.
Mr. Penn, I also have a question.
25 to infinity, yeah.
Well, so like in the problem, are they going to tell us what the restriction is, or we're going to have to?
Great
Okay.
question. They'll tell you that.
Okay.
That's something that they'll tell you. Yep.
All right. Thank you.
Mhm. Now, if you look back at this, the range is the y values. And the y values interchange, or so the y values start at negative 5 and go on up to positive infinity. So its range will be negative 5 to infinity. Well, what I mentioned a little bit earlier is this. When you go from a function to its inverse, the domain and range interchange. So there it is, kind of a nice example. All right, one last little comment here for this section. And again, it's one of the problems that you're going to work on. Actually, you know what? We'll kind of do two at once here. First part of this one is the graph of f. Is the graph of f a function? So just look at the red part. You can ignore my little lines here and here. Is the graph a function?
Yeah. Yes, it is.
Does it have an inverse?
Yes.
Yeah. So does it have an inverse is equivalent to saying, does it have an inverse that is a function? Or in other words, does it pass the horizontal line test? And yes, it does on both. So if it passes the horizontal line test, then they're going to say, okay, well, find its inverse at -1. Now keep in mind what happens when you're looking at the inverse of a function. The inverse of the function is going to take for input the y values and spit out the x values. So I've helped you out with these. This is your y value for the function. It's -1, which is right here along this line. What x value do you get when you find the y value of -1? What's your x value at this point?
2.
2.
2. And that's it. F inverse of -1 is 2. Maybe without my help, you can do the next one. If you're watching this later at home, you can pause the video, try and do the next one. What's F inverse of 2?
Zero.
So kind of like the last one, you got to start out and regard that as the y coordinate. So if that's the y coordinate, what x value goes with that y coordinate?
Be 5.
5.
Yeah, 5. So F inverse of 2 is going to be 5. Perfect. So those two right there. There is one last one on the homework, and I'll show it to you right here. Let's see. Right, where did it go? Ah, it can't be gone. Let me see here. No, no, where is it? No. I just saw it. So we're going to do this one kind of this way. I can't find the exact example, so we'll work it this way. The question ultimately is going to be this: find F inverse of 0. And that takes a little bit of thought. Let me move this up a little bit to kind of focus in on just the table. So all they're giving you is a table of values and asking you, okay, well, let's find F inverse of 0. What I would suggest first and foremost is just write another table and interchange these, because the table for F inverse is just going to be the opposite of this one. So I'll start out by writing 1, 2, 3, 4, 5, 6 for Y. And then over here, I'll write 2, 0, 2, 0, 5, 6, 3, and 1. So when you're trying to finish this one or solve this one, start out with the innermost parenthesis. They're asking you for F inverse of 0. If I input a 0, what's my output going to be? If I input a 0 for my
2.
X coordinate, I'm going to output a 2. Excellent. And now I want to go to the table for 2. I'm going to input a 2. What do I output if I input the 2?
1.
A 1. Yay. Let's do one more like that. Say F inverse of F inverse of, let's see,
2.
2. Let me just make sure 2 would work. All right, let's try a 2. Sure. So try and do this yourselves. I'll give you a minute to look at this. But kind of like the last one, start with the innermost parentheses. Figure out what F inverse of 2 is. Once you get F inverse of 2, then plug that number back in and try to figure out what F inverse of that is. So what's inverse of, what's F inverse of 2? Starting here in the middle.
It's not the 1.
Yeah, it's just 1. Plug in a 2 into F inverse, you get a 1. What's F inverse of 1?
6.
6.
6. Beautiful. And you're done. Comments on that last one? That one's a little bit of a trickier one. I'm glad we knocked that one off. So that's it for this section. Good luck on it.